Hello, linear algebra student. This video is for chapter 4.2, part 2. Continue with the discussion of null A. In part 1, we talk about null A, what is the definition of null A, and the fact that it is a subspace. And we also briefly talks about the process of finding the spanning sets, because that is also one way to convince people that it is a subspace, other than proving that other than theorem 2. And sometimes we want to write it out, right? So how do I do it? We do the reduced row echelon form. And this is the an example. I have a here, and I want to write null A, meaning the solution to ax equal to 0, or the sets of vectors that map the transformation T into 0. So we do the REF, and we have a reduced row echelon matrix like this, and then we're trying to write a solution. So we say A1, X1 is a basic variable, X3 is a basic variable, and we can write it in terms of others. X3 is equal to negative 2 X4 plus 2x5, right? And then there's no more. So x4 is free, x5 is free. So when it is free, we would write as x4, x5 is also x5. So this is null A, and if I am to write it, I will say null A is these that satisfy these, right? So if I write this, null A is the set of matrix. No, that's not a set of vectors. x1, x2, x3, x4, x5, such that um 2x2, oh, it is x2, x2 plus x4 minus 3x5, and then x2 is x2, x3 is negative 2x4 plus 2x5, and then x4 is x4 and x5 is x5, right? So where the free variable x2, x4, x5 are any real, right? So how can I write it as the spanning set if I have the description of it? So the spanning set would be you factor the x2 out, right? All of them can be written as x2. What is x2 about? So it's 2, 1. This doesn't have x2, 0, 0, 0. Plus x4. X4 is a free variable. X4 shows up in the first one, so it shows up as 1. The second one doesn't have. The third one has a negative 2. The fourth one is 1. The last one is 0. Plus x5. When does x5 shows up? 7, negative 3. 2. Oh no, the second one is 0. And then 2. Second one is 0, and then 2, and then 0, and then 1. Right? So this is how you describe it. So that means now A, I don't have enough space. Now A is spanned by what? It's spanned by this 3 vector, 2, 1, 0, 0, 0, comma, 1, 0, negative 2, 1, 0, comma, negative 3, or 0, 2, 0, 1. So because it's spanned by certain basic vector, we say that this must be a subspace. And that's how you find it. Okay, again, to find null space, you begin writing the augmented matrix A augmented with 0. Find the REF of this augmented matrix. Write the solution in terms of free and basic variable, and then write it in parametric vector form. So basically ignoring all the basic variable, but factor the free variable out. And then everything that are outside of the free variable, or that are vector of the free vector or linear combination of the vectors are the spanning set. So that's how you now write now A. Another concept is called column space. So if I have a linear transformation Tx to Ax, and then so the transformation is related to a matrix A, then column A is the set of all linear combination of A. So basically, it's like the range of the transformation, right? And we give it another name. It's called column A, which is the span of A1, A2, AN. Now, each one of the vectors, so if V belong to column A, meaning V is Rn, belongs to Rm, because it's V1 to Vm only, because they only have M row. So because we can write as a span of something, so a spanning set is a subspace, so column A is also a subspace. And the subspace but it is different from now A is a subspace of Rn. So the proof is, and you can see that the proof is because it's a spanning set. Okay, so clearly you can see that the range of the transformation related to Ax is actually column A, because column A is all the linear combination of all the column of A. So and when you do Ax is just the linear combination of columns of A, with x being anything in Rn. So find matrix A for some vector as column A. So if I have someone write me a matrix, can I find it? Find a matrix A so that it is a column A. So if I have a matrix that is 3A minus B, A plus B, 3A. So what does it correspond to? It corresponds to 3 times, no, A times, you can factor the A out, and then have 3, 1, 3, right? Plus B, factor the B out, that would be 8, or negative 8, 1, 0. So this W is actually a linear combination of these two vectors. So this is spanned by this, right? Spanned by 3, 1, 3, and also negative 8, 1, 0. And so this must be A. So A is the columns are the spanning sets. So we would say A is the 3, 1, 3, negative 8, 1, 0. So that column A, call A is equal to the span of these two, 3, 1, 3, negative 8, 1, 0. So it's really easy to do. You just do the rewriting. Example 2, so if H is this set of vector where AB is real, can I write it? Is it a subspace? Well, it is a subspace if I can write it as a spanning set, or if it is a column, it is column A. So I can write A, we can say H is equal to span of A 1, 0, 3, right, plus B negative 5 to negative 6. So, and it's actually equal to column of A, where A is equal to 103, negative 5 to negative 6. So it is a subspace. Column A must be a subspace. Okay, so what are some of the properties of column A? This is theorem 3. Recall in 1.4, in theorem 4 of 1.4, the columns of A span Rn even only if the equation Ax equal to B has a solution for each B. So, Ax has a solution. If Ax has a solution for each B, then the column space M times N is all of Rm. It will span the whole Rm. Okay. So let's contrast between null A and column A. So null A, let's talk about null A. Null A is about all those matrix. When you multiply with A, it gives a zero matrix. So null A is a subspace. We know that um, because of theorem 2. And how do I test if null A? We can just go through them. Null A is implicitly defined, so it means you know that um, you have to you are given only one condition. So the condition that a particular vector x belongs to null A is when you multiply with x with A is equal to 0. But to find a vector that span null A, you have to do a augmented matrix of A0. So it takes time to find a vector that span it. There's no relationship between null A and the entries in A. So null A is done by writing the solution of the augmented matrix of RREF of A and 0. So to find if a particular vector V belongs to null A, you just have to multiply A with V, and if it's 0, then it belongs to it. It's very easy to tell if it is belongs to null A. You just do the multiplication, just compute AV. And null A would only have one entry if the solution AX equals 0 only have the trivial solution. And also if the linear transformation is 1-to-1, then the only thing you can have, the only thing that is in null A is the 0 vector. What about column A? Column A is a subspace because you can easily write a spanning set. The spanning set is actually the column vectors in A. Column A is very well defined. You actually know what is the spanning vectors. How can I find some vector in column A? You just do some linear combination, or actually each columns of A is the vector. Of course, there's no relationship between column A and the entries, and there is a relationship between column A and the entries in A because each column must be in column A. Each individual columns are in column A. So how do I know a particular, if someone gives you a vector, how do you know it belongs to column A is if you can solve it. Okay, AX equal to V is consistent. There is a solution. That means you can find combination of A to get V. Okay, so you need to solve AX equal to V in order to check if V is in column A. And if a specific given a specific vector in V, a specific vector V, so it would take time to do it, to check it. You have to do A V augmented matrix to see if it's a consistent system. Column A would span Rm if Ax equal to B has a solution for every B. Okay, and then column A is exactly equal to Rm or the whole Rm if the columns are the linear transformation maps Rn onto Rm. That means every single one has a corresponding entry in Rn. So in the next video, we'll talk about how to determine if a particular vector is in null A, if a particular vector is in column A, and also write vectors in column A and null A. So that would be the next video.